Learning by Example Code C# for Beginners Part 3 Data Types. On the left we have data types of int, and on the right we have data types of double when declaring numeric variables. They both give the same output. Let's add 0.0 to both sides. The side with int gives us an error, while double compiles. Int or integer only allows for whole numbers. Double allows for decimal places. And this next one on the right is the float data type. In most languages, it requires that you have an f at the end of a real value or number when giving a float variable a real value. And it compiles. If we take out the f, it will result in an error. In this next one on the left, we have a mix of different variables and variable types, int and float. For x, we are adding the two integer values, and for y, we're adding the two float values. Remember, this /n is used to move the console to the next line. Also take note that it must be in quotations to work. X is 15, y is 35. On the right, it is identical to the left except for one minor change. I'm switching up the two different values for both x and y. And now we get an error. On the line where I'm declaring x, I'm adding an integer with a float. Number 1 being the integer and the number 3 being the float. I'm also adding an integer with a float here on the y line. Variables with differing data types do not go together unless you use a conversion function. We can get into those different types of functions later. These are the 6 data types that are used for numeric values and also the number of bits that each one uses in memory. You cannot directly give a certain data type a value from a different data type, like putting a float value in an integer value. There is a reason you must put an f at the end of a real value for a float variable and not for double. When adding the f, the computer will know to treat it as a 32-bit decimal number rather than the default 64 for the double. To get a better picture, when trying to put an integer of 32 bits inside of a short of 16 bits, there is another 16 bits of the integer that have no place to go and will give an error. They may also have the same amount of bits, but their characteristics may be different, like whole numbers versus decimal numbers. If you can memorize a byte holding 8 bits for whole numbers and a short holding 16 bits for whole numbers, here's a quick reference table to understand the other 4. Integer values range from 2.1 to -2.1 billion, and long values range from 9.2 to -9.2 quintillion. If you don't think a variable's value is ever going to reach over 2.1 billion, then integer should do just fine. In this next program on the right, we have the character primitive data type, or char. It only stores characters, or even a number. But it is not treated as a number. On this next program on the left, you see in char3 variable that we are adding char1 and char2 together, and it should be 3. But we'll get an error, even though they are the same data type. Adding 1 and 2 as characters is no different than adding, say, the letters A and B. They are only recognized as the characters themselves. The last one I want to talk about is the boolean value, or bool. This one is pretty straightforward. It only takes true or false values. Life is good, true or false. Life is good, variable. Execute. Life is good, true or false. True. Now this is not a primitive data type, but I'm going to give a little preview of strings, just in case you're wondering how to hold a string of characters. The data type char holds one character, and it represents 16 bits. Now a string of characters that are as big as a sentence or even a paragraph, with each character having 16 bits, can end up being a large number of bits. So instead, the string is a reference to an object, which I did not go over, but just know that it's not a primitive data type. Programming is life. Programming. In this next one on the right, we are going to add 3 strings together into string 4. Unlike the character primitive data type, strings can be added together in C#. The strings, or the values of strings, will be placed back to back. This cannot be done with any character data type variables, such as adding B to the back of A, as they must stay 16 bits. In the next tutorial, we should be learning about if statements.